Good morning, good evening, good afternoon. This is a joint webinar between the Catena-X and the OPC Foundation. And it's a personal pleasure for me to welcome here two dedicated experts. You see on the left side in your slide, Erich Barnstedt, Senior Director and Architect from Microsoft, but here speaking also for the OPC Foundation. And on the right, you see Thomas Obermeyer, Lead Data Space Architect from Catena-X. This joint webinar is about how both technologies can enable seamless industrial data exchange for the digital product passport. You might be wondering how both technologies perfectly fit together. But both experts will explain that in detail. After the presentation, please stay online. We have a Q&A and both organizations will share the slides and the recording. With this, I hand over, and honestly, I don't know exactly who is starting. Is it you, Thomas, or
yes.
Erich?
Yep.
It's Thomas. Thomas, the floor is yours.
Thank you, Stefan, for inviting us, and happy to give an overview here on the topic. So what we'll do is we'll pretty much look at 5 different points here. We'll look briefly about what is Catena-X and what's the history and why are we believing that joint working with OPC is a very strategic way for us. Then we look at what did we do so far, the joint initiative. We'll talk about a white paper that we have already developed together. This is reflected basically in a joint architecture, and we'll give you also some information on where you find more information so that you can basically look up what we are talking about today. So Eric and I will share responsibilities, we'll throw the ball back and forth. So hopefully this is also going to be interesting for everybody and not just a monologue of one person. All right, then let's get started. Just quickly, Catena-X, I'm sure you heard about it. Catena-X is a network for the automotive industry. What we are dealing about, how do we collaborate in a multi-tier environment and exchange data between different tiers, OEMs, recyclers, in order to, of course, reduce the cost and create synergies within our industry. So something that we started already in 2021. And we are live with this approach already. Just quickly talking about what is the overall foundation of Catena-X. And so we basically build our ecosystem based on 4 different principles or 4 different values. First of all, we believe that digital identity is something that we need to bring into the ecosystem for data sharing, for building trust, and to make sure that we all know who we are dealing with, who are we working with. Secondly, of course, interoperability, and that's something that the OPC Foundation is already driving since years or decades almost, right? So how do we ensure that we generate an ecosystem where people have choices, where there's no single vendor login? So that's something that is also the core, one of the core values of Catena-X. Thirdly, we believe that self-sovereignty is also a very important paradigm for us. So we want to make sure that whoever is participating in Catena-X can basically decide which data they want to share, how they want to share it, and they can control basically their intellectual property. So that's the third value that we believe is extremely important. And last but not least, this is something that we always call from the industry for the industry, right? So we want to make sure that the governance and the development of standards and the ideas are really driven out of the industry and not just out of a small group of thought leaders. So I already talked about that Catena-X is all about building data chains or value chains. You see that on the left-hand side, right? So we want to make sure that we can really build long-lasting chains from raw material producers, the various tiers, the OEMs, but also into the after sales processes and into the end-of-life processes like recycling, refurbishing, or anything else, right? So because only then we will get the next step from a linear to a more circular economy. And we looked at what are the alternatives. How could we build a system like that, right? So the first alternative, of course, is we build something like a central database. Everybody puts their data in there, and we're building a central place where all the information is located. Of course, I mean, there's, as I said, lock-in effects that we see there, intellectual property issues, cybersecurity, honeypot issues, right? So this was an approach we pretty much didn't select very early. Then, of course, the second one is just get one of the large IT providers in, build a system like that. But we see similar challenges there as well. And then, of course, everybody could do their own thing. That's what we see right now in the industry, which doesn't really scale and doesn't give us the effect, the network effect that we are looking for. So essentially, we ended up with saying, well, Catena-X really wants to focus on industry standards, making sure that we build something, as I said, from the industry, for the industry, focusing on how can we collaborate together, what are the important standards and agreements that we need to have, and allowing an ecosystem on top of that to thrive and to build solutions on top of it. And that's what we also see, again, a lot of similarities with OPC. How do we do that? We are focusing on 3 blocks. You see here the use cases, the standards, the interoperability. So we typically start with use cases in mind, with the product carbon footprint or the product path, which we will also talk about today a bit more, or demand and capacity management. So really areas of interest for our members where they basically articulate a need for improving the processes and the data integration. Then, of course, we're looking at how can we do that, right? What are the data formats, the APIs, security standards, and processes that we want to standardize across the industry, so across the different enterprises. And then we're looking at how do we build that in an interoperable way. And there we also learned, and I'm pretty sure that everybody knows that interoperability is not just about the data formats. We'll talk about that also a little bit more in detail. But we're also looking at what are the policies and the usage rules that are attached to data. How can we actually make sure that participants can easily onboard in such an ecosystem? And also, how do we build an ecosystem where different companies can build different applications on top of those standards? So that's how Catena works from an external perspective. And I just want to end this quick overview with a short view on how do we do that from an internal perspective. So internally, we are working in 2 different structure elements. We're working in what we call the committees, which you see here as orange rectangles. And we're working with expert groups, which are the green boxes here, right? So and the way we have structured in general is we say we have 3 areas of focus. We have the area on the left-hand side, scaling and governance. So how do we actually bring the ideas of such an ecosystem, such a data space into different environments, into different regions? So that's the scaling and governance part. We look at it from an use case specific viewpoint, right? So you see here the clusters of sustainability, engineering, supply chain and quality, and industry core. So these are the business-driven use cases, and how do we build standards and content around these. And then last but not least, on the right-hand side, you see the more technology focused areas where we talk about what are the technology infrastructure components that we need to create such a data sharing ecosystem. What are the onboarding, offboarding procedures? Again, connectivities, connectors, self-sovereign identities. So all those topics are more targeted towards the technology. And I just want to point out 2 things here, just as an example. You see in the sustainability area, we have, for example, a expert group working around everything around the digital product passport, something that we already also started some years ago, because we saw that this is a regulation that will be is and will be really relevant for the automotive industry. So there is a working group that works on the general strategy there. But we also have, and you see that on the very right-hand side, a battery pass modeling group. So a group that looks specifically on the first use case of a product passport, which is the battery pass. And as you can imagine, for electrical vehicle, quite an important use case for the automotive industry. And I want to point out here, we don't do that also there in isolation, right? But we're working closely with the IDTA together to build such a joint model. Using, of course, external input like the DIN spec 99100 to build something that is accepted across the industry. So it's not just Catena-X developing something. And this is where we also see the power of now joining with OPC, right? Making sure that we can build on that, extend it, so we have one common view in the industry. How do we deal with topics like, for example, the battery pass? And with that, I would hand it over to Erich just to give you a bit overview on what are we doing here in the initiative, and then we'll dive more into the details of the technology. Erich.
Thank you, Thomas. Next slide, please. Perfect. Yeah, so we got together with the Catena-X Automotive Network quite some time ago. I think it was almost a year ago now, where we reached out and said, hey, let's work together on this digital product passport initiative. Let's create something together that will accelerate interoperability. The OPC Foundation had been working on battery pass demonstrators for 2 to 3 years at that stage, and we realized that only through collaboration can we really make progress as an industry. So we reached out, and very quickly we saw lots of joint goals. Thomas mentioned some of them already, and it was relatively easy to create this strategic cooperation. We created a white paper specifically to write down some of the joint goals that we had. Obviously, industrial data exchange was the main goal. A lot of OPC Foundation members complain about the struggles that they have with getting, this data exchange digitalized in the first place, but then also increasing interoperability for that data exchange, creating joint models, creating joint interfaces, and so on, that people can really use across their customers and not just with one customer. This is especially relevant for the small to medium-sized manufacturers that don't have a lot of money to spend on IT infrastructure. And then, of course, the regulation around the European Digital Product Passport. This regulation will go into a little bit more detail in a minute. And then we, after we had written these things down, it was pretty obvious that, we needed a joint architecture, right? So this is kind of the next step that we did. We also tried to focus on semantic integration. So Catena-X had some templates, quite a lot of them actually. The IDTA had also some templates that we integrated. And then we said, okay, let's work on some open source together to really accelerate the implementations, make it available on GitHub, and then also look at how we can enable the ecosystem. So with that, we started, next slide, please. We started with the Digital Product Passport regulation. So as you probably know, this is part of the Eco-Design for Sustainable Product Regulation, or ESPR, which as an umbrella is part of the European Green Deal. So if you have been doing business in Europe, you probably heard about the European Green Deal. It's part of the climate action that the European Commission has put forward. So they want to be climate neutral by 2050. And a part of that is creating these circular economies. The battery regulation is already in force. So the battery passport will be coming from February 2027 onwards. All batteries that are over, I believe it's 2 kilowatt hours in size, require a battery passport, which has to be provided by the battery OEM. And that's for all batteries sold in Europe which are over 2 kilowatt hours in size. Also, all industrial batteries fall under that category, and all mobile batteries. So think e-scooters, e-bikes, electric vehicles, cars, and then industrial batteries like you would have as backup power for data centers, for example. So this is coming. We need to have this ready. Senelec is working on a standard in relation to the digital product passport as part of their joint technical committee 24. So this is all happening already, and we are mainly users of this initiative and making sure that our members have, an ability to actually be compliant with this regulation. Next slide, please. So what does it look like, in a concrete example? Let's say there are 3 actors, part of this example. So there's the battery manufacturer. In this case, let's say it's CATL on Alibaba Cloud, for example. Then there's an automotive OEM, for example, on the Azure Cloud. And then there's the customer of the vehicle, and they are using their cell phone. So how does it work in general? Well, CATL needs to deliver a battery passport. And again, this needs to be delivered in a way that is cross-cloud. So it has to work on Alibaba Cloud and the Azure Cloud in this example. And of course, then the automotive OEM needs to pass the battery passport along with the digital product passport of the entire vehicle onto the customer, such that the customer, when they're in the showroom and they want to decide which car to buy, can scan a QR code on the car. They see the car details, into the entire battery passport is part of that. And then they can make a buying decision based on the performance of the battery, for example. Next slide, please. So then what is included in a battery passport? Well, there are several different pieces to it. There's a digital nameplate, so the usual stuff that you would expect, like, serial number of the battery, who made it, when was it made, et cetera, contact details of the manufacturer, but also the materials used, and if there are any hazardous materials included in batteries, raw materials all the way from, materials that come from mines, et cetera, then most importantly, probably for European Commission's goals, is the product carbon footprint. So that includes all 3 scopes. So if you're familiar with scopes of CO2 emissions, scope 1 is basically the emissions from burning fossil fuels. Scope 2 are the emissions from using electricity. And then scope 3 are the emissions from the supply chain and the use of the product. So it kind of looks back in the supply chain and forward all the way to recycling the product itself. So this is obviously for manufacturing a big deal, and scope 3 emissions make up almost 90% of the CO2 footprint. So how do you get that information? Well, you need interoperable standards for your supply chain to make sure that you can actually access the data to calculate your product carbon footprint. And then there's some live data as well. So for example, remaining useful life of the battery, number of charging cycles, et cetera. So it's clear that you also need connectivity to the telemetry from the product itself. So every time you charge your car, your electric vehicle, there's a data entry that gets stored in the vehicle and eventually uploaded to some sort of customer database with the car OEM, and that data also needs to be accessed for the battery passport. And, again, this information needs to be part of the battery passport. So again, this is very complicated in terms of getting all this data readily available. And the cheaper the solution gets by using standards, the better for everyone. And then there's some owner information as well. So once you buy the car, your information will become part of the battery passport as well. So next slide, please. So this is, again, part of the battery passport, and there's a use case, or there's a joint initiative that Catena-X did together with a few OEMs and tier ones to actually build this out in general. So there's, like I mentioned, there's a lot more information that actually makes it into the battery passport, and there's a joint initiative between the IDTA, the Industrial Digital Twin Association, and Catena-X to really make sure that all aspects of the battery passport are captured. And there's a DIN norm already released, which has over 120 attributes defined, and obviously we want to make sure that all of these can be shared in the supply chain. Next slide, please. Okay, next. So we built this white paper together, released it back in July. So it basically highlights the motivation again. What is a battery passport? Why do we care, right? And then we also actually go into the joint architecture, which we're going to cover now in the next section. Next slide, please. And I should mention we have a resources section at the end of the presentation where you can directly download this white paper. So what does this Better Together strategy look like? So really, the OPC Foundation realized that only through collaboration can we really make progress as an industry many years ago, and we created this, what we call the Better Together strategy, where we're actively reaching out to other consortia, getting their technology integrated, and the work with Catena-X is a big part of that. So really you need 4 things to make standardization work. You really need a joint interface, something that you can use to transfer data. And then the data itself has 3 components. There's the data format, right? So how do you actually format the data being sent across the wire? How do you format the data that you store locally? That is covered in the data format. Then the data model is how you organize the data, right? So what modeling language did you use to build the data model? What does the data model look like? What are its properties? And then finally, what's in the data itself? So, the tags and values and so on, that all needs to be defined. And that's what we usually call semantics. So this joint story with Catena-X pretty much became very evident very quickly. So for the interface, we use a HTTP REST interface, which is open API compatible, which, if you're familiar with HTTP REST, is the de facto standard in the industry. There's version 1.3, I believe, of the open API specification that most people use. And then, as well as that, for authentication and authorization, we use the so-called data space protocol from the Industrial Data Space Association. The data space protocol is currently getting standardized as a joint ISO IEC project. For the data format, we actually use the OPC-UA nodeset file format. Why? Because most of the OPC-UA tools available today use that file format, and it's very common. It's an XML-based file format, but again, it's mainly the tool support that made us pick this particular format. It doesn't come as a surprise that we use the OPC-UA modeling language. So if you ask me what's the most important feature and reason for the success of OPC-UA, well, it's the modeling language, right? Because it has all this support in the industry. So the VDMA has over 300 companies working on OPC-UA data models using this modeling language alone, right? And that's one organization. And again, there are many more organizations using OPC-UA as the modeling language of choice. And then the semantics really come from several different organizations. Catena-X has over 200 templates already defined for things like digital product passport and digital battery passport. The IDTA have, I think, over 30 released templates, and there's a lot more on the way. And then the VDMA has actually released over 80, I believe, companion specifications, again, available for describing assets, describing machines, and it was clear that we want to build on this success to give as many standardized semantics as we possibly can to our customers, to our members, and make sure that they have the tools available for the job.
Mm-hmm.
Next slide, please. So do you want to start discussing this briefly,
Sure.
and then I'll take over?
Yep, we'll do that.
Perfect.
So essentially what you see here is basically two participants, right, of data exchange. So on the right-hand side, we are basically drafted how does a Catena-X participant usually uses technology. And here what you see is on the very right-hand side from a modeling perspective. When we started with Catena, we agreed on using what is called the SAM modeling, semantic asset modeling methodology. So all of our models are basically built with this methodology, but then basically exported as asset administration shell in an asset administration shell format and stored at a GitHub site that we have. We also have some what we call the semantic hub tool, but essentially the bare definition of the models are stored in GitHub and are publicly available to the community, right? And this is basically where, as Erich said, we put the semantics in there. I mean, how do certain data structures look like? What are the attributes, the information definition, and so on. So, and this template basically we provided to Erich and the team, right? And then there was the idea of saying, well, why can't we just use that and bring that into existing tooling, as we just learned, like tool sets and formats that is known to the OPC world, and the skills have been built up, tooling has been built up, right? And start using it here, and we will get to that, right? Ensuring that we can then use basically a data exchange that uses both worlds. And Erich, maybe do you want to just go a little bit more about the OPC stack?
Happy to, yeah. So the cloud library was an initiative originally from SESMI in the United States, the Smart Manufacturing Institute, and the OPC Foundation, mainly to store VDMA companion specifications. I mentioned the VDMA has over 300 companies working on these asset definitions, let's say, and they're in OPC-UA node-set file format. So we needed an online store for these node-set files and built the cloud library. So the cloud library has seen amazing success, mainly in the US, but also more and more in Europe. I know that a few automotive OEMs are actually using the cloud library internally, but there's also 2 hosted instances of the cloud library, one from SESMI, one from the OPC Foundation, that now have over 400 of these templates, let's say, available. So it was obvious that we would take the Catena-X templates, run them through a converter tool, which is available open source, and then store the resulting node-set files in the cloud library for public access, right? So this is what happens in step 1. And again, I mentioned these OPC-UA node-set files are generally used today by all OPC-UA modeling tools. So Siemens have a modeling tool called Sioma. It's Siemens OPC-UA modeling editor, I think that's what Sioma stands for, and it's available free of charge as a download from the Siemens website. It's pretty popular, but there's others. It really is your choice to use the modeling editor of your choice and the one that you're happy to use. And then we can store these OPC-UA node-set files, in this case, let's say a battery passport, in an AAS repository. And we've also now built AAS registry capabilities. And this is all built into the cloud library. So you can use the cloud library as a source for your templates, but you can also now use the cloud library as a AAS repository and AAS registry. And this is especially important because Catena-X used the AAS interface for data exchange, as well as the Eclipse Dataspace connector, more on that in a second, for authentication and authorization. the Eclipse Database Connector also has a catalog of available digital entities, let's say, for example, battery passports attached to it. So the catalog then interacts with the cloud library. We're currently working on a protocol that we call the data plane signaling protocol, which basically communicates between the Eclipse Database Connector and the cloud library to make sure that, you know, these things are synchronized. The data exchange itself then happens through the normal mechanisms that are already established in Catena-X. So there's a data transfer that happens through HTTP REST. There's a discovery that happens through the Asset Admin Shell Registry API. And then there are data contracts that are negotiated between two instances of the Eclipse Database Connector, which use the Database protocol, like I mentioned before. Thomas, anything you want to mention in addition to that?
I think in general, I think the picture is clear. Maybe one thing to mention is also, I mean, we are not just doing it between the two of us, right, or the two organizations, but of course, we're also looking at the other initiatives, which are called the Manufacturing X initiatives, like Factory X, Semiconductor X, Energy X, and so on. So there's more initiatives, but they all, I mean, have certain commonalities, right? So the question of how do we exchange data, there's what we call a MX port concept, which describes kind of like different configurations, because there's not a just one size fits all approach, but essentially it's all based on the components that you see here on OPC, on Asset Administration Shell, and on the EDC connector in slightly different combinations. But so that's something that I think it's also important to understand. It's not just OPC and Catena thinking about something, but it's really embedded in the context of the larger Manufacturing X initiatives.
That's actually a very important point. Thanks, Thomas, for calling this out. So the International Manufacturing X initiative kind of is the umbrella organization above all those industry-specific initiatives like Catena-X for automotive, and then there's Aerospace X as well, and Decade X for the defense industry, et cetera, and it's actually very, very important that we join forces with all of these different initiatives, because a lot of companies actually deliver their products in more than one industry. And of course, they would like to use the same tools and the same interfaces, data models, data formats, semantics, and so on for all their customers, right? And again, it's this collaboration and coordination that is so important, and this is why this initiative is so critical right now for the industry. Next slide, please. So very quickly, what is the Eclipse Database Connector? So it's part of a bigger initiative inside the Industrial Database Association. It's an Eclipse Foundation project, so it's all open source. And there's more than just a connector. That's why they call them the Eclipse Database Components project. And again, the connector is basically a piece that sits between two organizations. So each one has its own connector. One becomes a provider and the other one becomes a consumer of data. And the EDC is often referred to as the control plane. If you see that in documentation, you know what it means. So it handles authentication and authorization. It actually negotiates a digital contract between the supplier and the customer. And then data can start flowing between the supplier and the customer. And then the data plane is basically, in our case, the cloud library. And this is why we've been working with the IDSA and you know, building this joint architecture and building this new protocol that we call the data plane signaling protocol to make sure the EDC and the cloud library work well together. Next slide, please. So here is a picture of the actual converter tool that we mentioned. So it takes the templates from Catena-X, but also from the IDTA. They're available on GitHub. It downloads them. It automatically converts them as OPC-UA nodeset files. It does so through a OPC-UA server instance. There's also an asset admin shell environments service that basically understands the semantics of the asset admin shell submodel semantics or meta model, let's say, to read the files in the first place, and then stores notes.xml files fully automatically. So you can point it to a folder. On GitHub, you just go, file download the entire repo, stick it in a folder, run the tool in that folder, and then basically out pops a number of noteset files that you can then upload to the cloud library. So we've done that work for you. So all the IDTA and Catena-X templates are already available in the cloud library. But there's also upload functionality built into the cloud library now, so you can upload your own templates. Next slide, please. Here's basically what we did together with SESME, which SESME, I mentioned it already, the Smart Manufacturing Institute. It's part of Manufacturing USA, which is like the platform industry 4.0 in Germany. Department of Energy is behind it, just like, the BMWE is behind the platform industry 4.0. So this is something that we've worked with for many years, created, again, these noteset files, as we call them, smart manufacturing profiles, but they're just OPC noteset files. And, we wrapped it into this semantic model of the asset administration shell, and then stored it in the cloud library. You can see here, they also have an editor, just like Sioma. It's another editor this time. It's online, so you don't need to install it. They call it the Smart Manufacturing Profile Designer, and SESME hosts it. And again, it's free to use. And you can see here that we have the battery passport template already loaded in this particular screenshot. Recently, SESME has actually contributed this online OPC editor to the OPC Foundation. We've since renamed it to UA Noteset Editor because we thought that was a little bit more obvious in terms of what it is. And it became part of the cloud initiative, especially its open source component. Obviously, it's on GitHub, it's on the OPC Foundation GitHub, and we're working on making this tool even better and more feature complete at the moment. Next slide, please. So here's a screenshot of the cloud library functionality. We've also significantly improved, especially the interactive UI part of it. So obviously it has this REST interface that we already discussed, but it also has a UI where you can self-register, you can create yourself an account in the cloud library. You can then browse all the templates, for example, from Catena-X. You can make copies of it. You can fill it in with values, store it, download the values. So this is kind of basic functionality to fill out one of those templates with real values. But of course, we realize that as a tier 1 supplier, you don't want to fill one of these in for every battery that you sell to an OEM. This needs to be an automated process. So we're also working on connecting the cloud library to backend, ERP and MES systems and so on, and to make this an automated step, right? So that's another open source initiative that we're just getting started on. So again, we're trying to fill all the gaps, make it available open source so people can base their products on it, and really make the onboarding to the Catena-X and other Manufacturing X initiatives as smooth and quickly as possible. Next slide, please. So I already mentioned the cloud initiative of the OPC Foundation. I'm the chair of it, and it's pretty complete. So it has a shop floor component, a data space component, and an enterprise cloud component for the manufacturer. So here you see the components that are actually part of the data space. For example, for sharing digital product passport data. So you can see the cloud library there as the industrial data plane. You can see on the bottom right here, you can see the Eclipse data space connector as the control plane, like I mentioned. So there's one that the enterprise the one that the manufacturer would host in their enterprise cloud, and then the product customer is kind of the on the right hand side, the matching Eclipse Data Space Connector. The product customer may be an automotive OEM, so they will have some sort of ERP database. But you also see an Eclipse Data Space Connector on the top left, because again, it's a supply chain. So data would come in from the suppliers of that tier 1 manufacturer as well, using the same technology. So basically the arrow you see on the top left are the same arrows you see on the bottom right, just one level further down in the supply chain. And then of course there's, sorry, just one more thing. Then there are many different databases that feed data into the digital product passport. Like I mentioned, there's lifecycle data, there is usage data, there's things like bill of materials, right? Or raw materials used, product carbon footprint, et cetera, So we believe there are several different data sources that a battery passport will require, for example, right? So that's why it's so important that these databases can be accessed in the enterprise cloud of the manufacturer, and then data flows hopefully automatically into the cloud library for providing these battery passports and in general digital product passports. And I mentioned this needs to be an automated step. Nobody wants to sit in front of a computer all day filling out these battery passports for every single battery that they sell. So this is why this new component, the dynamic data processor, is also currently getting designed. And again, this is something that will hopefully automate the process. Now, next slide, please. So what does that then look like? For example, right? So again, these are all examples. Other examples, of course, exist, but let's say you are, in fact, an automotive OEM and you sell a battery to an OEM. Sorry, you're a tier 1 supplier and you sell a battery to an OEM. So this is where, again, you would download the template from the cloud library, use an OPC noteset editor to make changes or just fill in the template, and then you upload it to your instance of the cloud library that you want to make available to your customers. So of course you can also use the public instance of the cloud library for this step, but a lot of OEMs prefer to have their own, right? And again, the cloud library is a Docker, containerized Docker application, so it's very easy to host it yourself. It only has one dependency, which is a Postgres SQL database, which again, most cloud providers have available. You can also host it in your own container, but most OEMs prefer to have a cloud provider manage the database on their behalf. So it really is up to you, but the whole point is that this is a cost-effective solution, right? It doesn't use a lot of resources, and this is exactly what I believe the European Commission had in mind when they designed this. Next step, please, or next slide. So resources, let's have a look. So first of all, there is a joint working group inside the Technical Committee 65 within the IEC, and this is working group 29. We just had a kickoff of this working group last week, and we're going to basically pour what you have just seen into an IEC norm to standardize it and make it even more compatible with existing systems. So we're also looking at the Common Data Dictionary as a source of semantic information. Of course, the asset admin shell structure or meta model will be taking into consideration, and then of course the 3 relevant OPC standards that we discussed in this webinar. Next slide, please. So then we would like to briefly talk about the European Cloud Accelerator project. So this is a project that Microsoft started with the help of the industry So the Catena-X is involved, the OPC Foundation is involved, the IDSA is involved. And again, we're trying to make or enable European cloud providers with this technology, right? So we've reached out to CISB and a few other organizations that are, responsible or have, again, it's a consortium for European cloud providers. And we believe it's those European cloud providers that are uniquely positioned to make this a product for, European manufacturers to be compliant with digital product passport, digital battery passport technology. So everything that you've just seen is available open source, and we believe making this, industry grade, product ready is a next natural step in our journey to accelerate adoption of digital product passport technology. Next slide, please. So I already mentioned a big part of it is the open source initiatives from the Eclipse Foundation and the OPC Foundation. There's no dependencies on hyperscaler technology. So like I mentioned, the EDC is a Dockerized application. The cloud library is a Dockerized application, runs on any Docker enabled service. And, as a dependency, both just have a Postgres SQL database as storage. And you can share that Postgres SQL server between the EDC and the cloud library. So really, you're looking at, at a minimum, a containerized environment. That's all you need. If you want to go one step further, obviously a lot of European cloud providers also offer Postgres SQL as a managed service. So you can use that instead for the database instance. And a lot of them also actually offer Kubernetes as a fault-tolerant Docker containerized environment. So again, it really depends how much effort you want to put into maintaining these services versus getting the cloud provider to maintain the service for you. Next slide, please.
If I just add to it, just one more sentence, right? Because I think the European Cloud Accelerator program is something, of course, Microsoft initiated, but I think also from a Catena perspective, we really much appreciate that, because what we see is we still lack a bit the scalability of the data sharing concepts, right? So, I mean, yes, we have a lot of companies already investing in it, but if you look at the productive use, there's still room for improvement from a scalability perspective. And we're really seeing this as a central initiative to help us to bring data space technology with all the stack components that we talked about to a wider scale of companies, not just the OEMs, not just the tier ones, but also in the smaller and medium-sized enterprises. And that's why, also we as Catena are heavily investing here and want to make sure that this is a project that is being driven forward. Maybe that just as an additional information.
No, that's a fair point. And again, we're open for additional contributions. Obviously, if you are a cloud provider or you are in fact a manufacturer in Europe or selling products into Europe, you really want to be part of this initiative, in my opinion. And again, anybody can join. Please reach out to us, and we're here to really accelerate. That's why it's called Accelerator. We're really here to accelerate adoption of this technology. Next step, or next slide, please. Okay, the resources slide we talked about. So here are the links. So the press release is available, obviously, on the Catena-X and OPC Foundation website. The white paper is also available for download on both websites. Here's the Catena-X link. Then the cloud initiative, where all the components that we've just discussed are part of. There's a landing page on the OPC Foundation website. The reference architecture that you just saw is also available there, including how they map to the steering committee members of the cloud initiative. So pretty much all the major cloud providers and all the major automation providers are part of the steering committee and have mapped the reference architecture to their services. Then, of course, European Cloud Accelerator project and its landing page. So we had a kickoff meeting in Milan this spring, and then we had a follow-up meeting recently in Bergamo. And again, like the meeting minutes and everything we discussed so far as part of this project are available online. And then finally, you know, I mentioned the open source landing pages or open source pages. Here are the two from the cloud library and the converter tool that I mentioned. The Eclipse Foundation project is actually not listed here. We should probably add that. But so the Eclipse Foundation, if you search for Eclipse Foundation EDC, right, there's a landing page on the Eclipse Foundation website. You'll find it straight away. But you know, there's also significant open source work being done here in the Eclipse Foundation for EDC. So again, the idea is that, you know, hosting an EDC is very, very, very quick and easy, and there are things like a minimum viable data space project and so on readily available. So again, please have a look and, you know, reach out to us if you're interested in contributing. And with that, I think we're at the end. Do we have another slide?
Nope, we're at the end.
Yeah.
I can hand it over to Stefan, I guess, for the closing words.
Yeah, thank you.
Thank you so much, gentlemen. It was a pleasure for me to listen. I learned a lot from you, and I also love your passion behind. So people are really seeing that you are burning to educate the people and share knowledge here. We are switching over to the Q&A in a second. Again, the material, the slides, and the recording will be shared by both organizations. With this, I say, first of all, thank you officially, because we are stopping the recording here. Thanks for all attendees being online. Thanks to the speakers. And let's stop the recording, please.